Hello, welcome to the fifth and final tutorial I'm doing around applying VSEPR theory. This video is again for students who are studying advanced chemistry at the post-16 level, particularly for IB. If you're studying IBHL, then this is for you. What I'm going to be focusing on in this video is ions with 5 or 6 electron domains, so a little bit trickier than molecules, and hopefully you're going to find it useful. If you're studying a different post-16 subject, such as, or a different board I should say, such as A-level or otherwise, then hopefully this can still be quite useful. So before I go any further, I want to just identify the links to the IB curriculum. It's from section 14, which is the higher level part of unit 4. And the understanding is the same as before. Its exceptions to the octet rule include some species having incomplete octets and expanded octets. In this case, we're going to focus on the expanded octet part. And the application skills are exactly the same as what I talked about in my previous video. It's the deduction of the Lewis structures of molecules and ions. I've put ions in yellow because that's what this video is going to be about today. And also using VSEPR theory to deduce the electron domain geometry and the molecular geometry with 5 and 6 electron domains and the associated bond angles. So I'm going to go through a few examples. Again, similar to the last video, I will assume that you are familiar with the bond angles and the shapes of normal molecules which have 5 or 6 electron domains and any lone pairs and how that affects the shape. We're just going to do the application here. So I'm going to start off with the mnemonic that I use in order to deduce this, and it's the same as what I always use. Dirty Vinny bit my crystal dust early morning. And they mean the same things as I've discussed before. Now again, I'm not going to go into detail about what they mean. I'll leave that to you to go through in previous videos if you want to hear more about them. What I'd like to do is just jump straight into an example. So the example I'm going to go through today is ICl2-. Okay? Now let's go through the whole procedure. So first I have to draw my diagram. So I've got iodine, and I've got chlorine, and I've got chlorine. Okay? That's what my molecule looks like. It might not be accurate because it might be in a different particular shape, but we'll find out later. The next thing is valence electrons. Now I know iodine is in group 7, so I start off with the number 7. And now I need to work out the number of bonds. Now it's got 2 bonds, so it's 7 plus 2, which equals 9 electrons. Now I need to take into account multiple bonds. There are no multiple bonds here from my understanding, so I'm going to leave that as 0. I now need to take into account charge. Now if you look at the charge over here, there's a minus, which means I have to add another electron. So 9 plus 1 equals 10 electrons. Next step is to divide for electron pairs. So I've got 10, I divide it by 2, and that gives me 5 electron pairs. Okay. Now what I can do is I can move to the E part of my mnemonic early, which is the electron geometry. So I'm just going to draw it out here. I've got iodine in the center, and I've got 5 electron pairs. That's a trigonal bipyramidal electron geometry. So there's one here, there's one there, there's one there, there's one here, and there's one here. Okay? So my electron geometry is trigonal bipyramidal. Okay? Now my next step is to work out the molecular geometry. Now before I do that, I'm going to be quite fancy and work out what my bond angles should be like for a trigonal bipyramidal structure. The angle between the top and bottom electron domains and the one in this plane should be 90 degrees. And there should also be an angle of 120 degrees between here, here, and here. So I'm also going to put in 120. Now that might have to be changed later, that's fine. We'll do that once we deduce the molecular geometry. Now let's have a look at the number of atoms I've actually got bonded to my chlorine, my iodine rather. I've only got 2 chlorines. Now I need to decide where to put them. I'm going to put one here, and I'll put one here, and whilst we're at it, let's just put the brackets in and the charge. Now that leaves me with 3 electron domains which aren't occupied, so they have to be lone pairs. And I'll just represent them by dots. Now if you look really carefully, you'll notice that this molecule has 10 electrons attached to the central iodine. It's an expanded octet and an ion. Now I could redraw this, and if you're sharp enough, you can see that actually the chlorines are on equal sides from the iodine. So my molecular geometry here is linear. Okay. Now my previous bond angles for trigonal bipyramidal don't apply here because the whole reason why we had 90 and 120 was because of these three in the middle. These are now just lone pairs, and if it's linear, it has to be 180 degrees. And that is my bond angle. To finish off, I have to take into account any other lone pairs. I've got chlorine here. It has 7 electrons in the outer shell. It's gained 1 from iodine to complete its octet. So in this case, I just have to put in my 3 lone pairs for it. And that's your molecule. You could redraw it if you wanted, so it could simply be Cl, iodine, Cl like so. Here my lone pairs are my chlorine. And you could do something like this if you wanted. And a few brackets. But for me, this is where you start, because this is the most clear diagram of what it would look like. All right, so that's ICl2-. Let's do another couple of examples. My next one is ICl4-. Okay, so again, I'm going to draw my diagram. So I've got iodine here, and I've got a few chlorines around it in whichever shape. Okay, just a rough idea of what it would look like. Next step is my valence electrons. Now, iodine is in group 7. So it must have 7 valence electrons. Next step, number of bonds. I can see 1, 2, 3, 4 bonds attached to it. So 7 plus 4 equals 11. Right, that's number of bonds. Next step, multiple bonds. There are no double or triple bonds here, so we can skip that step. Let's now look at the charge. I look at this molecule, it has a minus. So it has to be 11 plus 1, which equals 12 electron to play with. Now I have to divide for electron pairs, so 12 divided by 2 equals 6 electron pairs. So now let's work out what my electron geometry is, which is the E for early. Iodine is here. I must have something above and below. I've got something there, a domain there, a domain there, and a final domain there. Okay, that's the rough electron domain shape, so it should be octahedral. Whilst we're at it, let's predict some bond angles. The bond angle, because it's octahedral, should be 90 degrees, and we'll tweak that later. Now let's work out molecular geometry. Now I've got 4 chlorines, as you can see, attached to the central iodine. So let's put those in. 1, 2, 3, and 4. Now that leaves me with 2 electron domains which aren't used. As you can see, they have to be lone pairs. So I'm just going to put dots above and below it, and I'm going to finish it off with some brackets. Just to make it really complete, I have to consider the lone pairs on the chlorine as well. They have 3 because they're in group 7. So let's put them in 2. Okay, that diagram's done. Now let's work out what the name is the molecular geometry. It's got 4 chlorines around it, and the top and bottom domains aren't used. So this is an example of a square planar ion. The angle between each of the chlorines actually doesn't change because these repel equally from either direction. So the bond angle stays at 90. Okay, so that's ICl4-. Let's do one more. Let's do I3-. Now I3- as a diagram, I'm going to assume looks like this. We'll see how that goes. We've now got to do valence electrons. This is my center, so I'm going to consider this A. So it's got 7 valence electrons, and it's forming, and I know that because it's in group 7. Moving on, number of bonds, it's got 2 bonds, so I'm going to do 7 plus 2 equals 9. There are no multiple bonds here, but there is a charge, a minus, so I have to add 1. So 9 plus 1 equals 10. So I've got 10 electrons. I now have to do the dust, which is divide for electron pairs, so 10 divided by 2 equals 5 electron pairs. Okay. Now let's draw out what the structure looks like for the electron geometry. Iodine's in the middle. I've got 5 pairs, so it should be something here, and something here, and there, and there. Now, my electron geometry has to be trigonal bipyramidal. Okay, I've got the 3 here, and then 1 top and 1 below. So it's trigonal bipyramidal. Bond angles, as I've done in previous examples, should be 90 degrees because of this, and 120 degrees because of the angle between these 3. Okay, 1, 2, and 3. Now the only thing I have to do to finish off is work out the molecular geometry. Now the molecular geometry is depending on what I've got. I've got 2 iodines attached to the central iodine, so it should be 1 here, and then I've got 3 other domains which aren't used. They have to be lone pairs. Okay, I'm just going to close it down with brackets and charge. So this example, as you can see, it's linear because you've got iodines either side, and you've got the 3 lone pairs here which take up that space. So this is a linear molecule. And again, 19, 120 do not actually reflect the accurate bond nature here. What it is a nice 180. Okay, and that's how you do it. So I hope it's been useful going through how to deduce the bond angles and shapes for ions with 5 or 6 electron domains. Good luck with deducing the rest.